Very exciting. Remove the damaged area. Fabricate a brand new piece of aluminum to fit that exactly. We have to put what is called a doubler on the back side. We'll talk about all this later. You don't have to worry about it right now. There's a rib. Got to make sure it's reinforced. And then specific size and type of rivets. If you don't get this repair done correctly according to specifications, weight could be off. You could have cracks propagating from your incorrect repair, which could set up unusual vibrations, which will propagate throughout the wing, which could cause your wing to eventually depart the aircraft. Based on the drawing that you or your partner have completed, hopefully everyone loves their grandma, would you want your grandma to fly in the airplane a repair was done based on your drawing? Very good. The good news is, in this class, you'll learn how to read and make correct drawings. In sheet metal class, you'll learn how to do correct repairs, so grandma can fly safely. But this was hopefully fun, maybe silly illustration of why knowing aircraft drawings is so important and why we have illustrated drawings. Because if you had to read paragraphs of words and try to do a repair based on that, grandma's not going to fare so well. And also language can be confusing. English is supposedly my first language. I don't really have a second language. Except I say English is my second language, so I really don't speak it that well. But if you leave out the little comma, you might say, let's eat grandma. Uh-oh. Hopefully you say, let's eat grandma. Moving along. So, now that you hopefully understand the importance of why we have drawings and why we have to learn about how to interpret them correctly, a drawing in aviation can be thought of as the link between the engineer and, I don't know if you can see that very well, the AMT. Look at
Oh, that's a comfortable position.
You get to look forward.
I skipped lunch to do this.
Is that Ryan? Same fan.
That's actually Zach Francois. He is a missionary of MAF, student here. Yes. So, sent me that picture like, oh, that's good. I can put it in my PowerPoint. I make fun of engineers. I don't know if I can. My brother is an engineer, so he's like, yeah, you can make fun of us.
Please do.
But they are the brilliant minds behind what we do. There are many days I'm studying maintenance, and I'm like, whoa, this is so cool how it works. And I'm like, wait, somebody figured out how to make it do what it does, that we just fixed. So I actually do appreciate engineers. Sometimes they design things that make it a little bit difficult to actually work on. It's all right. But they're generally, it's the engineers completing the drawings that then we say, okay, how did this work? How did they design it? We can read that, interpret that, and then do the actual physical work to repair it. Because things break, and that's why they need us to fix it. It used to be, not terribly long ago really, you would have actual paper drawings, and if you were going to make a drawing, you would have to use all kinds of special tools and equipment, measure out angles, lines, all this stuff. We are going to do a teeny tiny little bit of that, but not using all the drafting equipment they did back in the day, because we now have CAD. So big lot for CAD. You're going to figure out that I love puns. If you don't like puns, you can groan. That's what I like. with them, make sure you know how to input the correct data. But it's super nice. You can input all your specifications, and then it'll make it 3D for you, so you can turn it, spin it, look at any angle you want without, back in the day, then I had to draw this out, taking many hours. And then draw this out, a couple more hours. And then draw this view. So every single view, much time involved. Now, input the information, does it for you. Beautiful. You will have the opportunity to work with some paper drawings. Please treat them with care, because most things have been updated, put in online. But there are some things, like if you're working on old warbirds, they may still just have paper versions of information you need. So do not be doing this. Don't put anything on a drawing. Nope, that's bad. Get marked down. If I could have a volunteer, if anyone would be willing to read page 4-2. I'll look for a volunteer in a minute. First, I'll let you know what you're volunteering for. So, page 4-2, there is a kind of red letter outline, care and use of drawings. The volunteer can read that whole section under care and use of drawings up to types of drawings, just to help us focus in how do we treat these paper drawings. So, thank you.
Care and use of drawings. Drawings should be handled carefully as they are both expensive and valuable. Open drawings slowly and carefully to prevent tearing of the paper. When the drawing is open, smooth out the fold lines instead of bending them backwards. To protect drawings from damage, never spread them on the floor or lay them on a surface covered with tools or other objects that may make holes in the paper. Hands should be free of oil, grease, or any unclean matter that can soil or smudge the print. Never make notes or marks on a print, as they may confuse others and lead to incorrect work. Other authorized individuals are permitted to make notes or changes on prints, and they must sign and date any changes they make. When finished with the drawing, fold and return it to its proper place. Prints are folded originally in an appropriate size for filing. Care should be taken so that the original folds are always used.
Thank you very much. So, go ahead, the drawings out there that you will work with. But I have a couple here. I'm going to be showing some things on them later that I want you to be looking at. But I keep these in a special folder in my file drawer so they don't get messed up. But I'm always careful, unfold them, because all of these were hand drawn. So we could make copies of them. We need a special copy machine to do the whole thing. But a lot of these, we only have the original. We don't actually have copies of them. So you unfold it carefully, and then very carefully make sure it's not creasing. Ooh, that I could have ripped it if I yanked it across the desk here. And then just smooth it out. I don't do that because I could tear it. So just go along the creases and kind of flatten it. And then it could tear on this little piece of tape up there. Lay it out. And then I keep everything away from it. I'm not going to lay anything on top of this. I'm not going to, as I talk, grab my coffee and let my coffee come over. So I know that'll be a time when I go whoop, sploosh, and it's gone. So these are pieces of art. In antique, probably. So high value stuff that people put hours of work into it. So respect it and treat it with care. And you may lay another drawing on top of the drawing. It's not going to hurt it. There are any questions on treatment and care of drawings? So there are standards that must be met. This is not something you have to memorize, but you do need to be aware to abbreviate things, because if everybody chooses a different abbreviation, then nobody knows what anybody says. What symbols mean. So these are the guys that define all of that. So everything else we're going to talk about in this class, if you're questioning in your head, why do they do it that way? It comes back to these guys, whoever came up with it. So we're going to talk about 3 types of drawings, and this is in your textbook, page 4-3, if you're following along. It goes over detail, assembly, and installation drawing. And you may be asked by the FAA, what are 3 types of drawings? And these are the 3 you would say. Yeah.
Well, I really should have asked this earlier. Are we always gonna, like, the copy prints that we mostly work with, are we gonna treat those the same way we treat antiques, like the handle ones?
So it's still good to treat that the same, because you might have to print out another one,
Sure.
but it wouldn't be quite the same disaster if something were to happen.
Okay, thanks.
Good question. Yeah.
Does the paper size matter now in the AVG-CAD?
You still need to know what scale it is, but they will, that's more important than, how, as long as you have the scale, it will, they will have the paper size accurately. So the 3, and also, another note on my classes, if I say something like, you will be tested on, that does mean you will be tested. Very likely in my class, and I do try to prep you for the things the FAA will ask you. So, I want you to be very well prepared and not surprised. So a detail drawing is a description of a single part. And we'll do this. If I had this screwdriver, this is a very lovely screwdriver. It's not ratcheting, but it does have interchangeable bits. So if I were to do a drawing of this entire screwdriver, a detail drawing would be just this tip, which is only one part, or it could be this handle, which is only one part. And that would be a detail drawing. It'll have lines for dimensions, notes on it of anything unique, symbols it might have. It'll tell you the size, the shape, and the material it's made out of, and they're usually pretty simple. We're going to talk about types of lines, types of notes, types of symbols, all that stuff, but they'll be included in a detail drawing. And you might have a couple different views. So like this bracket here, we have the back of it, front of it, where we see this comes down, and a side view that shows us, oh, it's like an L, so this part actually comes out like that. Can't really tell it on a flat drawing, but given the 3 different views, you can tell that.
This drawing, where we can find the material that's
That's an excellent question, and it's super fuzzy, it might say it in here. It doesn't always. Sometimes you have to go to another place in the manual for that, and you'll find that when we get into sheet metal class. There may be different descriptions of the part, and it'll only give you the material in one place, even though there's multiple drawings of it. We'll talk about that more later, but good question. Yeah?
What's the difference between like a drawing and a draft and a sketch?
That's a very good question. We will talk about that. The difference between, yes, those things. some little lines here showing that that all gets assembled together. So that helps you that an assembly, you're assembling something, so you need more than one part. So two or more, it can get complicated. It will describe the size and the shape. It is more complex than a detail drawing. But here's the tricky part. Don't let it trick you. An assembly drawing will include detail drawings. So like right here is the detail drawing from our last slide, but now we got a detail of this, and then it's showing us all these little rivets. So it's detail drawings coming together in an assembly. And the last type would go from one detail to an assembly. The next step in progression is installation. So how do the parts go into the aircraft? So it includes all of the info for the final assembly. So in the aircraft, able to work, part of it, ready to go. It must have specific dimensions. So it'll tell you tolerances, which we're going to talk about, what's allowed, dimensions of what the part that's going onto the aircraft, dimensions of the aircraft, parts around it. An example could be that we could have a detail drawing of just this prop blade, and then we'll let the prop take the whole prop off the engine. But if I could take the whole prop off the engine, then I could just have the hub, the bolts, and the propeller, and that would be what kind of drawing? Very good, assembly drawing. And then if I show a drawing with the propeller on the engine, that would be a
Potentially.
I can't give you all the fun stuff, but I'm not sure.
Hey, what's going on out there?
I did it.
Fire truck?
Well, Dean's watching. Good.
It's,
I understand. I mean, we could do something like this.
Is it like a street group like that, or is it from next?
Terry Polish on it.
Oh. Yes. Ask me. Yes. Or Terry. Oh, is that for the ones like cancellation? Yes. Yeah, Nick right there.
Menards is right there over by every Walmart or just down the road.
did you read this whole report? This one's actually not written in the middle of the chart. I mean, kind of tells
I
the
did a
story.
car repair one time that needed to cut the socket this big. We had to get the knock sensor out first. The 27mm socket.
What was over?
40.
What do you want to do for a baby? Oh, plug my laptop in.
Wow.
On the front of your desk.
I told myself, it's not laziness, it's constipation.
No, no.
Through resource management.
Yeah.
There's that.
What? What? I don't know, but it feels like full hard. No. Oh, it tilts. Slightly terrifying. It's a drafting table.
Oh, yes, that's
Set it up on my table. Sketch. Oh, yeah, yours has the power strip. So what do you need? Get more grip. Get grip. Ah.
that's one.
Come on.
cheating, it's called using your resources.
When the teacher in sheet metal says, use it,
Okay, the memory key on the back.
This is not for drawing.
Yeah.
sheet metal is,
Oh, I don't know.
Yeah.
but you'll use a straight edge keyboard. Alright, let's get started again. And we're moving along in your textbook, page 4-3, where it says sectional view drawing. So this is a way of portraying an object that you can see what's inside of it. So another way to think of it is a cutaway to show the shape or construction and to show that the part has been cut away. It will have section lines because it's a sectional view, or otherwise known as cross-hatch lines, so it does go across. We're going to talk more later about different styles of cross-hatching lines to tell you what type of material it is, but don't worry about that now. Just you'll see some type of cross-hatching, and then you're like, ah, this has been cut away. So, the last couple years I taught drawings, I always had a number of people that kind of struggled with visualizing a half or a full section, or we'll also talk about a half section. And I'm always thinking, how can I teach better? How can I illustrate things better? So I like visualization. I like 3D models. So I went and found some foam, cut it out, and then I was pretty tickled with it. It's a little worse for the wear, but anyway. So this is supposed to be, you may need to use your imagination a little bit, this here. I didn't get the little holes because I was afraid I was going to destroy my tender, fragile object. But it does have the basic outline of it. So you could say this is our 3D model of this. And then if I do a full section, which means I cut it halfway, don't let that confuse you. At the halfway point, I cut it the whole way across. So it is a full section. Boom, there we go. So I'm cutting it clean across, and it looks like there you go. So I removed this. Now I have half section with my little cross hatch lines. What did I just say? Full section. If you hear me say things and you're like, wait, I don't think that's right, please call me out on it, because words come out of my mouth that were not planned in my brain. Full section, and very cool example is a stapler. Did you ever wonder what it would look like if we split this in a full section? Well, that looks something like that. So you can see all the intricate inner workings of an Umbel stapler. This is a cable connector. You're going to learn about those in Ryan's class, but they just did a full section, and all the special, unique cross-hatching lines we'll learn about later, which tell you different materials, different areas are made of. And then this little object, ooh, they give different views of it, which we'll learn about, and just cut that. Now, if that is a full section going the whole way across, next is a half section. So they show that by the green line. They go, whoop, only halfway, stop, and they're just taking half of a full section. So here, you can see by the cross-hatching, we stop right there, and the other half you see the actual outside, and they do a 3D view of that. And let me see if I can put this back so that we have a half section. Oh yeah, there we go. So, like that. So taking the whole thing apart, we just removed half of it. And we but it is showing this kind of flipped on its side. Here's those screws, this is a picture of it just to kind of get an idea. Otherwise, if you're like me, when I first took this class, I was like, what in the world is that supposed to be? I don't have a clue. Well, you have a little clue. Then we have a revolved section. So this is taking part, and now normally it would be cut the whole way through, but it's staying in place, just rotating it so you can see what this inner portion actually looks like, what that shape looks like. So they will show you a line to show you where it's cut out of, and then they'll take it and turn it, boom, so you can see what that shape is. And this is a nice 3D view of it, and the cutting plane right down the center, and it just turns. Same thing for this, rotated just 90 degrees so you can see the internal shape.
You said that there'd be most likely a question on what type, like different types of drawings this can contract.
So, thank you for asking that, because I want to make a note on that, how it's laid out in your book. The detail, assembly, installation are types of drawings, and if you look under the red heading types of drawings, that first paragraph says drawings may be divided into three classes: detail, assembly, and installation. So sectional view should be another heading, because in your book it looks like it just follows under those three, but thank you very much. That's something I did want to bring up. Because you may have a sectional view as part of a detail or assembly or installation to show you what that looks like. Cut away half of it.
It's called like some type of key.
Yes, correct. Yep. So sometimes we just have to revolve it 90 in place, and that gives you a good idea of what shape it is. Other times, it takes a mini vacation and they remove it away from the part. So they show you we're cutting right through here, but so you can get kind of a 3D view instead of just a 90-degree rotation, they will remove it from the part and set it to the side. So on this one they have a view right here, move that out, and you can see it is also revolved, so they did turn it, actually turned it, as well as this one, they cut it here and rotated it. So a removed section might also be a revolved section, depending what they need to show. But it will be pulled out and away from the original part they're trying to show. Yes.
Okay. So just to clarify, the
Yes.
one on the right is also a removed section as well as a revolved
they would say, is this, is this a assembly, an installation, or a remove section? Because it is both remove and revolve. Now, if they give you a select all that apply, and it's more than one, and I am going to give you examples of FA questions. I do that for all my classes, so you can get used to how they ask. Because that is a very good thing to think about.
From my experience from piloting,
Yes.
that's exactly the type of question
Yes,
they ask.
they do try to. Yep. And there'll be a couple that we'll go over specifically that I'll say, in this situation, this is what they're looking for. So, yeah, because I have not seen one where they would do that in this specific situation. So you're correct, they do like to be tricky.
Are these types of detail drawings?
These are, so, here's a question for anyone. Is this, or is it a detailed drawing? I'll take it, actually, the group vote. How many say, yes, that qualifies as detailed drawing? How many say, I don't think so? Ooh. How many say, sorry, take a nap? Very good. So, those of you that say, not so sure, what are your reasons? Yes.
No measurements.
No measurements. Good. Yes.
There's no actual details, like you said, measurements or material.
Or no. Very good. Any other?
It looks like an assembly drawing.
It's not showing you,
Parts come together.
right, it is only one part. So, if we go to the book under detail drawing, it is a single part. Yep, I agree with that. It is a single part. But then, described by lines, notes, symbols, specification for size, shape, material, methods of manufacture. Now, it doesn't have to have every single one of those, but it does have to have something of that. It is simple, so it meets that criteria. But we have no idea how long this is or the width. We don't have, the other criteria. So technically, it doesn't meet all the specifications of a detail drawing. Very good, thank you. Yes?
On the figure on the right, those arrows, that, A, also B, are those arrows indicating which way you're looking down? Okay.
Correct. Yep. So this, we are looking that way. Like if we were to take this and rotate it like that, you're looking down the length of the shot. Yep. For both of them. Very good. Yes.
So this means that
So this,
just coming from the sectional.
correct. Correct. I removed, and also this one is also revolved. Very good.
It's just a tough schematic to kind of
It
wrap
is.
your brain around.
Yes. Yes. And this is from a radial engine. So I think we might have one out in the shop. I might plug it in here after next break. Yeah, but there'll be other drawings. I'll ask you to do more interpretation of. This is more just to show. Okay, this is what the 3D view looks like for the piston rod, and then this is just flat 2D. Yeah.
So it's like more like a sketch than a drawing. You don't have to-
Yeah. You're jumping ahead of me. Correct. Yeah. Very good. Okay, guys, hope you go fast. Well, I had to say it now while you still, no. No, you will be. Full confidence. You'll make us proud. sometimes they'll have it along the edge, or it might be at the top right. So go to the bottom right if you have a good drawing to find it. But if it's not there, they're just doing what works best for the way the drawing is laid out. But these are some things that you need to be familiar with. What is included in a title block, because you are going to be creating some title blocks. And this information is on page 4-7. If you want to refer to it later when you're asked to do a lab that you're doing a title block for labs, unless I tell you otherwise. As far as I can think, for my lab, always you are able to use your textbook as a resource. So if you like to mark your textbook, you can will mark by points 1 through 6 that are included on a title block. Now different companies will arrange it a little differently. They might have different information, so this is not hard and fast rule. Generally, you do have to have a drawing number. And we're going to talk about how those numbers are created. And then, obviously, the name of the part or the assembly, if it's an assembly drawing. So people aren't trying to interpret the drawing, just go. Words are good sometimes. So we do have the words to say what it is. And the scale, is it a full size? So for every inch on the drawing equals an actual inch on the part? Or is it maybe half scale or quarter scale? Or is it a tiny part and we are making it larger? The date, so they know when you made a drawing. We'll talk a little bit how it's very important to get the most recent data and information. So you need the most up-to-date. The date is important. The name of the firm, if you're working for someone. So when you do a drawing, if you're doing it for SMAT. And then the name of the draftsman who actually does the drawing. Somebody will come along and check it, make sure everything is correct, checked by someone. Some places will then also have somebody approving. Might just be 2 people, might be 3 people, maybe big company would have more people. So this changes on the company how many people, names or initials will actually be listed. But drawing number, name of assembly, what the scale is, the date, the name of the firm, those things do need to be included. And then whoever does a drawing, and if somebody is checking it. There may be on a drawing, these are some additional reference, or they're maybe called draft numbers, or dash numbers, sorry. On a drawing, you'll see arrows that refer to what the information is talking about. And you might see a reference. So here we have a line to here, but then we have a reference. So there might be a whole separate sheet of paper, a whole separate drawing to give more detail. So you can't fit that on the one that already exists. So that will tell you what drawing number to refer to. There may be more than one detail. Most commonly, you would have, so for aircraft drawings, if there's a right and a left part of something, they will always show the left one. Whoever came up with that, always show the left. If for some reason the right is different, they may specify that by a 1 versus a 2, or they might just say left hand and right hand. If for some reason it shows right hand rather than left, that will be specified somewhere in the title block. There'll be an extra section saying this is actually the right hand view. So left hand always shown. Right hand, they do have to tell you that in the title block. Or it may be right beside the part in the drawing. They'll say this is the left hand, refer someplace else for the right hand view. And then the numbers would be the part numbers of that part.
Where would be the reference? It's referring to where you go once you see the reference.
Correct. So that either means And the more you're in the manuals, you'll get used to what Cessna likes to do, what Piper likes to do. In a maintenance manual, most of the time it'll be a part number. Illustrated parts catalog, for sure it'll be a part number. Some manuals, it might be a reference to another drawing, which would be like a page or two over. So you could turn and see, oh, okay, this is a drawing. Or they could tell you, possibly they could have more blocks in the title block and say, these are the references it's talking about what that means. Or in notes somewhere else in the drawing.
In that drawing, it would tell you where to go from there.
Correct.
Okay.
Yep. Yeah.
On some of the drawings provided in the book, they don't have all this information.
Correct. They don't. And yeah, the reference and the dash numbers, like if it only shows left-hand parts and there's not another detail, if it's simple, they don't need that. So these are just additional things you might come across, but it won't be in every single drawing. Something else you don't need to memorize, just be aware of its existence, is a universal numbering system. And this identifies the drawing size, like literally what size of paper it's drawn on. Unfortunately, even though it's called the universal numbering system, many firms and companies do not follow it. So it's in your book. It's on, I'm not going to go read through all those. It's on page 4-8 under universal numbering system. You will be asked to refer to this, not memorize, know where it is at in your book. So if you need to look up the number on a drawing and figure out what it means, come to your textbook, read through that. So you might have a number that starts with 1 or A, alpha, and then a bunch of numbers behind it. If it starts with a 1 or a 2 or a 4, it will tell you what size that paper is. So if you only can see, for whatever reason, the bottom corner, and your drawing number starts with a 1, you know it's on a 8.5 by 11 piece of paper. Or if you got a bigger paper but you don't want to measure it, some mean instructor is asking you for the size, you just go to the front of the number, and if it's a 4 or Charlie, you know it's 17 by 22. So that, yeah.
All of the examples in the book either have 7 or 6 as your starting number, not
Yes.
1.
Yep, so that'll tell you, okay, yes, so those are not part of this. So some firms will not even follow this.
Is this information found in like the FAR AMT or it's just expected for mechanics to have their general book handy at all times for their careers?
Well, so for testing, so your oral and your written, you are not allowed any resources. But for your practical, now they are allowing you to have your textbook with you. It used to be you could only have AC 4313 and maintenance manual, but they do allow this now. And I haven't seen questions yet on the written about this, but it's in the textbook, so we have to teach it, and it is out there, something you might run into, and oh, what's this size?
It's just for practical purposes.
Right. And they might ask you on the practical, if they ask you questions during the practical, you can refer to your textbook. They kind of expect you to. If you just rattle off the answer, they might get, are you sure? If they ask you, are you sure? Probably won't. Yeah.
So these numbers are all found at like the beginning of like the drawing number?
Correct.
Is that where every okay.
Correct.
That's not me.
And I'll have an example in a minute.
Oh, that's perfect.
But
Thank you.
yeah. And again, not every drawing follows this.
Yeah.
But the drawings that I will numbering system. Any other questions on that? Yes. Double check your textbook. Yeah, it's not there. 1, 2, 4, or 5.
Great.
3 lost a day, apparently. It's an excellent observation. Any other questions on that? So, the other thing that should be included in drawings is bill of materials. Now, since we are on airport property, we refer to it as a BOM, not what it would say. But I just had to throw a picture in there because exploding things are fun. So, your BOM, or bill of materials, is a list of materials and parts necessary for fabrication or assembly of component of system. Basically, the stuff that you need to put it together. So here you got rivets. Yay, I like rivets. And this is our bill of materials. So it is going to list the part number. So you can go to Aircraft Spruce or your favorite aircraft place, order your part with the correct number. It'll have the name of the part, so you don't get confused. You have double check the name and the number. The material, so you're sure to get the right type. The quantity required, so you know, do I need 10 or do I need 100 of these? And the source. This is really nice. So we have a bill of materials for our aircraft maintenance program. So we know how many sheets of sheet metal to get, how many rivets to get. For every class, we have a bill of materials, and we list where to get the stuff. So when Anna B orders it every year, she's not going, which company did we get this from? She's like, oh, boom, this company here, and we can order it. So these are the things in a bill of materials, and that is listed on page 4-8 and 4-9 if you need to refer to it later.
That's the far right side right there.
Correct.
Is where it came from.
Correct,
That
on the
tag.
drawing.
Okay.
Yep, and I have one to show you. Let me see if I can flip it over. Back to me. This is one missing. Okay. And I would like to mirror, please. Make sure AMT classroom. I always wonder what would happen if I did it inside. And do that. Oh, ha 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 ha, look at that. All right. And we've got, so some of these are going to be super tricky. I'm sorry, I'm in some of your way. But, well, and I'm very wobbly. So there is the items, notes added, and then over here, you've got approval, some dates, and I'm going to, making me seasick for a minute, sorry. Open up this drawing, it's a really nice bill of material on it. And truth. So that one I just showed you, it's pretty hard to read, it's old, the ink's kind of running. This one here, whoa, it's a very nice bill of material. So you have 8, 6, that's the number of those rivets, and it does tell you there's a rivet, there's a lock washer, there's a washer, bolt, so it tells you what the part is. And then that it's on the drawing, so it tells you number required, part number, name, material, specification, size, which is not right on there. Yeah,
Is the metal, that's the material specification?
correct.
What is that? What are we looking at?
If there would be more, like another category of specification than just cause, whoa. So the AN 45685, in that it gives you all the information on the material. Should have somebody else go up and all this that you need. But if there's more information than that, whoa, this way. Woo! Over here would be a spot for additional information if that didn't give you what you needed.
Okay, so does the AN mean something?
It does. And we'll learn about issue now.
Okay.
But that tells you,
Along with the numbers, the 86.
correct,
Okay.
correct, all of that, oops. There you go. This is why I'm a mechanic and not a photographer. So yeah, the AN tells you, the 456 tells you additional information, the AD tells you more information, the 5 tells you other information. I won't move you down with that now. We go over that in detail in sheet metal class. So that was, and you'll see on the drawings I have out there, the bill of materials, the title block, kind of how all that fits in the drawing. They won't always have a bill of materials. For example, if all of these rivets were exactly the same, and this assembly only required those rivets with hardware, it might just have a note in the drawing itself and say these are AN 456 85 rivets. Right in the drawing itself, it might not make a whole box for the bill of materials. You won't always have a bill of materials. Depends on the drawing, how much hardware there is. Questions on that? Then it may have a revision block. So if someone came along and said, you know what, this part would be better if we put a little angle in it. Or, ooh, they come up with better hardware. We need to put different hardware. But we don't have to redo the entire drawing. We can just revise it. So typically at the top right-hand corner of the drawing will be a revision block if it has been revised. And it'll have a description of what was revised, and then who did it, so name of who revised it, and the date when it was revised, because you have to make sure you are using the most recent information. So it might be in the upper right-hand corner. More commonly, it will be adjacent to the title block, which is where, typically? Bottom right-hand corner. So, depends. But somewhere in the corner of the drawing, whether it's top right, bottom right, next to the title block. But, and we're going to talk about this in a lot of the classes as it applies, you always have to make sure you are using the most current version of whatever you're using. So if it's a maintenance manual for System 172, it's got to be the most current. So drawings, look at the revision block, make sure it's the most current. Otherwise, if you're using, oh here we go, boom, must use most current version for your particular aircraft model and serial number. If you use what is not current, when you go for your oral and practical testing, and you pull out a very old, tattered version of Cessna 172 maintenance manual, the DME is going to say, nice try, see you again, and then you'll have a sad day. So, most current information. Yeah.
Say I have a paper form of the one just for the most recent. Is it just
small note. But if it's larger notes and takes up more space, they'll put it up in a corner and then give you a number, a little circle, an arrow to what it's talking about, and then you're like, 4, huh, what's that? And then you come up here like, ooh, all bend radii shall be 0.125. So then you know, okay, that makes sense. In here, we got 3 has another note for it. So it gives you additional information, but it might be referred to by numbers.
Those numbers that are going to be part of those part numbers, rather than notes.
So they will somehow, and there's not a universal way to do it, but within the drawing itself, they will specify the difference. So here on this drawing, the 4, and you can, like I would be like, oh, if it's a longer number, is that a part number, or is it talking about a note? So then I would look at the drawing and see, is there notes on the drawing? And then if that 4 corresponds to that 4, like, okay, it's a note. But if it's a part number, maybe like, there should be a bill of materials. So then I would go down to the bill of materials, and if that number shows up there, like, the part number. So that's kind of taking in all of the drawing and seeing what it refers to. But yes, you could have a number being a part number. Typically, part numbers will be many numbers.
So you might have covered this, but the 4 there, is that referring to the note, or is that referring to the bill?
In this situation, it is referring to the note. And they would somehow specify that, like they could use letters to refer to their notes, like this could be A, B, C, D, E, rather than 1, 2, 3, 4, 5. And you'll see some examples in the drawings when we get to the lab.
So there's also this item number, and it looks like that either lines up with the notes or with the parts on the tile block.
Where are you looking?
This image 4, 4, 5.
Oh, yeah.
For that part.
What?
Because the note says all bend radii
Oh, yeah.
shall be 21 to 5.
Yeah. So, yeah, I see what you're talking about. Very good. That actually, you're right. So yeah, Matthew, what you were saying, that 4 is going down to bill of materials. And the quantity, so the item would be the 4 here for a Cherry Max rivet. And yeah, so all bend radii is 0.125. There isn't a specific area where it's 0.125, it's all bend radii and all corners. So yes, thank you. So that is correct on this one, and that was perfect. I was like, wait a minute, I need to take all the information in this drawing, and we learned that in this situation, the 4 does go down to bill of materials, and number 4 in the notes just refers to all bend radii. I planned it. Yeah.
So would the rest of the notes all just be general as well?
In this one, let's look at them. Talks about the finish, so that would be general, because that's the whole thing. Part will be marked in accordance with tech number, so that would be general. Mark part number and revision letter in contrasting color, general. All bend radii, all corner. So yes, but you may see what I was talking about. If a note is referring to something specific, it might specify, might be in the drawing somewhere. But as part of fun of reading drawings, getting all the information, seeing, oh, is this bill of material, or is it notes, or are all the notes general? More questions, because I hope I didn't confuse you all with that. Okay.
like, what's this number? And I'm like,
Yes. And I think, I'm trying to prep you with all the information you need for the lab when we get to that, but when you get to the lab and you're looking at entire drawings, I think it all comes together. Because then you're like, oh, okay, this is what that is, and, yeah.
But most of these title blocks would be for assembly drawings.
Most of these are, yes.
Because the title blocks for the detail drawings are pretty simple.
Right.
You still planning on cutting spiders also?
Oh, yeah, probably a demo panel.
Tomorrow?
I think Case is on tomorrow, so I don't know when I'm doing. Oh, yeah. There's a whole
You had the wrong one anyway.
Alright, we're gonna get started again. And, oh, and I also just, I don't think I said this yet. So I know these first 3-4 weeks, they're all lecture heavy and it can be brutal. I remember when I was a student. So if you're feeling tired, please feel free to get up, stand up in the back. If you need to do like, I don't know, push-ups or, that's fine with me, as long as you're not too much of a distraction. But yeah, now also, side story, I never drank coffee until I came to SNAT, and SNAT did me in. As you can see, drink it all the time, but anyway. So, not offended at all. In fact, encourage you if you're feeling sleepy, stand up, get your blood flowing. Alright, maybe this will get your blood flowing. Anybody? Matt, recognize that?
Oh, yeah.
Oh gosh, yes, this is back from 23. That was the last time I was there. Hopefully I'll go again soon. Anyway, so threw this into drawings class because if I told you control tower is right there, hopefully you can see some of this. I don't know, there's weird numbers at the top, letters down the side. What could that be? If I told you the control tower is, oh, it's kind of in the middle, a little towards the top. Is there a better way for you to tell me where exactly that control tower is located on the map? Yeah. Yes! Very good. So,
K11.
K and 11. So I follow 11 down, K across, so I boom, nailed it, control tower. So, in drawings, these have a special name. They are called zone numbers because they tell us what zone we're working in. So, it's like a good old-fashioned map. I may be aging myself, but how many of you ever drove with a good old-fashioned paper map? Oh yeah, hey, oh, this is encouraging. So it would go from, my mom taking out the atlas and my dad driving. And then when I came along and started driving, we actually had, MapQuest. You print out page after page after page and then you're driving along and I lost a page, I'm lost.
And we're lost in the middle of nowhere.
Where's that paper go? Anyway, but there will be letters and or numbers on the border of the drawing, and I don't know why, the way to do it, numbers are read from right to left. So just tuck that away, know that when you're looking at it, it's like, okay, we start over here, and then letters from bottom to the top. People that do the drawing, they can fish it up, but typically this is how it'll be. And exactly what we did with the Oshkosh map, they help to locate a point. So if there's notes that talk about something or in the bill of materials, they may say, find this part at 5 Bravo. So just locating a specific point, and this would be more useful on a really big drawing where you have lots of area to cover.
Is it like say number or letters? Does it matter?
That's a really good question.
1A's a radio show.
I don't know the answer to that. I'm gonna have to look that up to see if there is a universal way. something we as mechanics specify. Manufacturer might say for a Cessna 172, my datum is a vertical reference from maybe the firewall, maybe the nose of the aircraft. Some of them like to do weird things, like it will be 36 1/4 inches ahead of the firewall, and it's like, ew, you know how to measure it. You'll have fun with that in weight and balance. But it's established by the manufacturer, vertical reference from which forward and aft measurements are made. So it's just a reference point so you know where the landing gear is, where a seat is. And a lot of this is for weight and balance purposes, because if we throw a seat on the tail, our aircraft is going to have a bad day and boom, back in the tail it goes. Or if we throw 1,000-pound lead on the nose, boop, we're not going to take off, we're going to meet the trees at the end. So then, datum is our vertical reference. When we measure from there, we measure station. So a station is a location on an aircraft identified by a number, designating its distance in inches from the datum. What that means is, start at the datum, measure back, and station 100 is 100 inches from the datum. That's all it means. How many inches from the datum it is. And I throw all this verbiage in here. First of all, tongue twister for me. But mainly because this is FAA lingo that we kind of have to get used to. So I'll throw it in there, but then give you the Christina version of it. So station, inches from the datum. Little tidbit from weight and balance. If this datum is back here at the firewall, anything aft or behind it is going to be a positive number. So positive 222. If it is forward of it, it will be a negative. We'll talk about the why and the application of all that in weight and balance. Do you have questions? Matt?
Why is station 0, 0, 0, or fuselage station 0 and waterline 0 so far forward and below the aircraft?
So, like fuselage station here, 100. So this one is because, this is labeled a little bit weird. Our vertical line here is the datum. So then this would be 100 inches from that. The water line on this one, and that's in my next couple of slides, but it is actually this line, which is a little bit weird on this one, a horizontal measuring point for upward and lower measurements.
Well, why is the datum 100 inches in front of the firewall? It's not even on the plane.
Correct. That's the manufacturer. And in weight and balance, we're going to talk more about that, but it has to be a fixed location, so a measurement, like this one probably is 100, that'll say in the manual, your datum is 100 inches ahead of the firewall. So then, and this is what we do in weight and balance class, our Cherokee, I think, is similar to that. So you have to measure from the firewall, make a mark on the floor that you, everything's leveled and clean, and then measure out 100 inches ahead of that, and then draw up a chalk line, and that's your datum. And now you go back and measure everything else from, which is a pain. It's really nice when manufacturers just make it the firewall for you, or make it the nose of the aircraft. But for whatever reason, sometimes they'll help. Sometimes I wonder if manufacturers sit in their big cushy office chairs and say, how can we make this most difficult on our mechanics? Because yeah, logically, there's another question over here.
It was answered.
Okay.
Maybe I missed this, but let's just say for simplicity, the datum is the nose cone, the tip of the nose cone.
Correct.
If I'm measuring 2
nose of the aircraft is like this plane, this flat wall that's invisible, obviously, but you would measure everything from this point out in this situation. But the manufacturer can be like, haha, that's that slice of the plane firewall. Or, oh, you know what, we're gonna make things difficult. It's 365 inches ahead of the firewall. Move things along.
Yes, nowhere on the budget.
Most of them they're, yeah.
Would it be a dumb idea just to like hold the frame up, or we'll just build the wall, and then we can just move it from the wall?
Let me think that through.
Probably easier to measure on the floor than you
Because everything
Well, yeah, but.
write that down, bring it up and weight and balance. Because we can actually test the theory.
Planes and me up.
That's a little difficult because you have to level the plane and then things move and then it's easier to do a chalk line than to move a wall. It's good thinking though. Do you have a question?
If you just subtract 100 for the datum and just use the firewall, can you just do that instead? Try not to worry about an extra chart line.
Save that for weight and balance. You're gonna get me teaching a whole other class early. You'll be the advanced class. We got weight and balance flipped out and drawing. All right. So the datum is the horizontal invisible wall. Then we're going to slice the aircraft right down the center, like that. And if you have a tandem aircraft where passengers sit behind the pilot, don't think too much about this, but the manufacturers use the term butt line or buttock line. So that is right down the center of the aircraft, and measurements are going to be made right and left of that line. So it'll be specified right or left because it'll be one or the other. So you have right butt line of 47 inches or left butt line of 229. So right and left do have to be specified with that. Yeah.
There's positive and negative too, right?
On
From that line down the center.
not for the butt line because it is either right or left.
Okay.
The datum could be negative.
Instead of being like forward and aft, they gave it a designation of negative and positive.
Correct.
Yeah.
Yeah. And now we come to the one we were asking questions about, the water line. So that is, and this one is way down here, which is interesting. I mean, if there was water, I would want my airplane to be above it. But
Considering if it was only 50 feet.
you have vertical references. So I could say the bottom of my landing gear are waterline 50, which again is all inches, and then waterline 100 is about the center of an aircraft. And on a waterline vertical locations, that's not used, not very common. But line right and left, especially for wing locations, and for sure station numbers from the datum, very much used. But waterline, know that it exists, but not very common to have references from the waterline. And station numbers, don't get scared, can be quite expensive.
That's a big thing.
So when you have a large aircraft, you're going to have station numbers for any piece of equipment that matters. And they will also split the aircraft into sections so you know for maintenance purposes where you're working, where something is, locations of something. Yeah.
Do civilian aircraft have station numbers on the aircraft? Like where the ribs are?
Right.
and-
Like labeled on the aircraft itself.
the inside?
typically, no. Because like for a wing, we have to actually measure, so military aircraft do.
Military
That's so
aircraft,
nice.
yeah.
They're brilliant.
You would just like walk through, like, oh yeah, this is station, whatever.
Wow. We need to up our game. Oh, that's pretty cool. Yes,
I think I missed this, but for the right and left lines,
yes.
is left positive or negative?
So it will just be right hand or left hand.
Oh,
No
right hand or
positive.
left hand, okay, no, okay.
Correct. Any other questions on this station run? Now, we get into just a teeny tiny little bit of math. Just teeny tiny, don't be scared. And you can very much use your calculator if you need to. I don't think you'll even need to for these. So, allowances and tolerances, and you do need to know the difference between those, difference between the two terms. Thank you. Sometimes I just cross myself up. Because this is an oral question, they'll ask you this in written, so I'll try to help you because I forget what is what. So, in a part, you are typically given an allowable variation. So we'll just do that little section out. But we could say, this depth here, let's say it's supposed to be 1 inch. So from the top here to the bottom here should be 1 inch so it can fit in where it's going. But we're gonna allow, it can be up to 25 thousandths larger than this, or it can be 5 thousandths smaller than this. That's allowed, and it will still work. So we can be positive, a little larger than the given dimension, or it can be negative, a little smaller than the given dimension. So the allowance is the difference between the given dimension, in this case, 0.225. That's what we want it to be. That's our goal. We're trying to nail 0.225. But we can be 0.0025 greater. That's allowed. Or we can be 0.0005 smaller than 0.225. That's allowed. So when you're asked what the allowance is, it's the difference between the given and either the upper or the lower limit. So 0.0025 would be the upper allowance, 0.005 the lower allowance or limit. However, the tolerance is the sum of the plus and minus allowances, or the way that helps me is the total for tolerance, the total amount that you can be off. So you would just add 0.0025 and 0.0005, and that would be your tolerance. So, if we take this, throw it down here, and go 0.0005, let's put our little holding place there, and what is 5 plus 5? Woohoo! Carry the 1, 2 plus 1, and then my 0 is to hold it. So, man, you guys are excellent at math. Woo. So now, 0.0030 is our tolerance. A lot of people get thrown off by this negative. That just shows you that's the smallest it can be. You're not doing anything with that when you do the calculation. You're simply adding numbers together. Just simple addition, that's it. So, with such advanced students as I have, we have 0.045, and then our upper allowance is 0.032. Our lower limit is 0.025. So if I go, I wonder what my tolerance total, that's a funny vibe, is. We've got 32 thousandths plus 25 thousandths. 5 plus 2 is what? And 3 plus 2 is what? 0 plus 0 is what? So now we got 57 thousandths as the total for the tolerance. Now you may see this when you see it in a drawing next to a part and you're figuring out what is my allowances, what are my tolerances. You might see it written out like this, like all just in one row. Or you might see it written like that. So your main number is going to be larger, and then each allowance is written smaller. And it's nice they put the upper limit above, the lower limit below. And so for 20 thousandths plus 20 thousandths or minus 10 thousandths, what would be my tolerance? 0.030 or 30 thousandths. And then if you may have just, or let me rephrase that, your allowance might be the same for upper or lower limit like this one. It's plus 10 thousandths and minus 10 thousandths. So if it's the same, they'll just write a plus, a minus, and then what that is. So it means it can be 10 thousandths larger or 10 thousandths smaller. So what will the tolerance be? 20 thousandths. Beautiful.
So when you got 3 decimal places like you have here, is it better to say 10 thousandths as opposed to 1/100?
Yes, and very good question. We're going to talk about that in math, but it is for precision. So if I measure 10 hundredths, I have a really cool slide in math about this, but you're measuring more precisely the further out you go. So measuring for 10 thousandths, because if it was 0.011, we're out of tolerance. Whereas if I was only measuring to hundredths, it didn't be that precise. It wouldn't matter. Excellent question. Any other questions on differences? Yes.
So is allowance like a hard rule? Like it cannot go past 10 thousandths?
Correct.
But then what's the point of knowing the tolerance?
That's a very good question. It's a term they want you to know because technically when you take a part and you manufacture it, you're going to measure and say, okay, am I 10 thousandths off of 0.232? So what would my upper allowance actually be anyway?
0.242?
Exactly, 0.242, so that's what I would be measuring to make sure I don't exceed that. Did you have?
Yeah, it's the lower the box, is that the allowance, and then lower right box, the 0.232 is that. I'm sorry, add that backwards. Is that tolerance on the lower left and then allowance on the lower right?
So for this one, my upper allowance is 20 thousandths. My
What is
lower
allowance?
allowance is 10 thousandths. Tolerance is those two added together, like how much
Which is what
total.
we see on the right.
And this one is, the upper allowance is 10 thousandths. Also, the lower allowance is 10 thousandths. So if you can be from I'm gonna be pounding you on allowances. Because you're gonna do sheet metal projects, and then I'm gonna be measuring them to make sure you're not exceeding upper or the lower allowance. But yes, machining engineers, that kind of stuff, they'll use tolerances. Any other questions on that? It is reading. Don't let it put you to sleep. So then we move on to finish marks. Not something you have to memorize, just be aware you might see them on a drawing, and then you can come, they would have somewhere you could refer to know what they mean, but they would just use a symbol in the drawing to save space. And it indicates that the surface must be machine finish, which means you need to leave a little bit of extra so it can be machine finished, and you're not taking it down below the lower allowance when you machine it. So just a simple check mark means machining is optional. Want to make it look nice or not? The filled in, or not filled in, but the full triangle finish is required. A little circle in the check mark, removal of material not permitted, and we've got symbol of the bar added, special surface feature required. I would tell you somewhere in notes what that feature is. So just be aware that they're there.
Can we find these drawings anywhere? Are they in the book?
So these, I don't think these are, but it would tell you somewhere in the drawing it would have the term just left you, but it would tell you, yes, thank you, what that means. Somewhere where they would have room for a legend, and then throughout the drawing it could just put the little symbol to save space in the full drawing itself. Yeah.
Okay, so we don't really, it's not really important.
Correct, you don't have to memorize them, just when you see something, oh, that must be a finish mark. Yeah. Then, I talked about scale. The scale indicates the size of a drawing as compared to the actual part. So, if it's 1-to-1, that means it matches. Or it's full size. Indicates that the drawing is the same size as the part, which later on you're going to be doing a full scale sketch for this class. 1-to-2, and you can think of these as fractions, is just 1/2. Same as 1-to-4 will be 1/4 quarter scale. And that will be down, oh, I can't find it right now, but in your title block will be the scale, so you know how to change that for your actual part if you're making the part. On a drawing, if you want to, and in sheet metal we'll do this, we'll make a paper template of the part to lay on the sheet metal, trace around it. But don't take your template and lay it on the drawing or print out a copy from online and copy it, because on CAD it might be zoomed in or zoomed out. The copy could vary from the original. Actual paper shrinks and distorts. So make sure when you're duplicating a drawing that you're using actual dimensions, actually measuring everything, not just copying seems easy, but it could mess you up. So don't just directly copy it off. And then there can be kind of application notes, separate than a regular note. Yeah.
When you're like upscaling a part,
Yes.
the bigger than it would be like an income fraction of the scale.
Correct. Correct. Yep. Good question. Yeah, so it would be like 2-to-1. Yeah. Application is just a specific application for that part. So you could have a similar part with slightly different application on different aircraft. So this an aircraft, or maybe different for a different assembly or sub-assembly. It's any sort of unique application. So you might see, it would be somewhere in the title block. If it has a specific application, it would tell you that. Not super common, but just be aware if you see the word application somewhere in the title block, you can think, okay, this has a unique purpose. And then you would read and it would tell you what that is. Any questions? Yes?
Are we gonna be using capital or?
We're going to use, it's called Tiny CAD, I think. It's a free CAD, probably Wednesday or Thursday, and do just some super simple electric schematic stuff. But yeah.
I think the book says that, what's the most common, like you guys use SolidWorks or like for, aviation?
Right. So in aviation, like our LLC, we don't do a lot of drawings or designs. Really depends where you go. Like down at JARS, North Carolina, they design a lot of their own things. Like they come up with special S-frame seats to save pilots' backs, and there's a lot of other things they develop tools. So they would have whatever the latest, greatest CAD program. But like our LLC, we're doing inspections, routine maintenance, everything is already drawn in aircraft maintenance manuals. And then if they would do, like you guys are going to do a repair, you're not going to do a repair in this class, you're going to do a drawing. And sometimes it's, well, jumping ahead of myself, but you're required to provide in the logbook information that you use to make a repair. So if that's in the manual, you'll just write the reference. But if you slightly modified it within specifications, then you have to provide a drawing of how you modified it. But it'll be so simple, you probably just hand sketch it onto the FAA forms and not, yeah, it would depend what shop you go to, if they have something or not. All right, I'm going to introduce you to, woohoo, FAA testing. So excited. So, were you all given the prepware software yet? Excellent, very good. So these are prepware questions, and I'll put them into my PowerPoint. Sometimes they'll be at the end, sometimes they're interspersed, but I try to cover all the prepware questions that are for a class, in the class, and then, here's your tidbit for the class, most of my classes, and I'll tell you when they're not, most of my classes, the finals will be prepware questions. So, if you like to study, which I recommend for your final, if you review prepware questions from my classes, you'll ace the final. Generally, and I'll tell you when it's different. But they will look something like this. And we'll go through them. They are always multiple choice, some version of multiple choice. This one gives you two statements. And then you have to figure out, is this statement true or false? So down here, this can get really confusing. Like, only one is true. Either one or two is true. Both 1 and 2 are true. Or I might say, oh, this. I ignore that. That gets me all sorts of confusion. So I decide first which one is true or false, and then I come down and see what matches my correct answer. Hopefully correct. So I'm going to take a class vote on these. Statement number 1 is, they say, a detailed drawing is a description of a And then we have course presentations. So these are all of my PowerPoints, and typically I'll wait to upload them until after the class so that I can have your full attention and you're not on your computer too much. But then you'll have access to those. We'll talk about, in resources, I'll put in here whatever you need for the class. So I have the Cessna single engine structural repair manual, we'll be referring to later on. And then we get to lab assignments. So this might show up on yours as a quiz. Don't get freaked out by the word quiz. That's just how we format it in Moodle, so Moodle can grade it. These are labs. You use all your accepted resources. Textbook, manual, no Googling. So these, now you get to see the great secret. These are all the ones I have kept hidden. But you should be able to, on your Moodle, see number 1 and number 2. So anyone that doesn't see those in their Moodle. Okay. So I'm going to open up number 1. So if you click on 141-1 Drawings Basics, it should take you to something that looks like this. And we will give you whatever information you need in lab instructions and the information. So all this one says is complete the following questions regarding drawing basics. That's the stuff we covered today. So then you can either hit here, next page, or over on the far right, you can also navigate through the questions if you're like, I wonder what question 9 is. You go, boom, question 9. And then, oh no, I went way ahead. And then you can go back to number 1. Phew, okay, I'm at number 1. Or you can go back to information, back to where we were, and then you can think, all right, I just want to go in order. Just hit next page, boom, and it takes you to question 1. And I try to do this, tell you what reference to use. So it says, according to your textbook, what are the 3 classes of drawings or types of drawings? And you'll look in your textbook and select all that apply. So if it says all that apply, that's probably more than 1. And then you'll go through, I'll just click through some of these, what class of drawing, class and type, those words are interchangeable. And all of these, you should be able to figure out from your textbook saying the different types of drawings. But I'm going to skip ahead to question 9. And I would invite you all to join me on question 9, and we're going to take a look at it together. So on the right side, go over, hit question 9, boom, and then I have to scroll down a bit to get the whole thing. Anyone not on question 9? Okay. So it says, and this is some stuff that got put into this lab, we're going to talk a little more about later, so I want to go over this one together so nobody's lost. Examine the drawing below. What is the dimension, we're going to talk about dimensions I think tomorrow, for the area within the red extension line. So we'll also talk about taking all the information in of a drawing once we talk through what all that information is. But we can see, okay, they did this with CAD, that's pretty cool. We got a part number, a spindle hub, all right, this is our, what is this? What is the name of this block?
Oh, what is the name of the block?
Yes.
Sorry.
there. And this is looking down from the top. So we got kind of two views of what's going on. So they're going to give us some information on this view, some information on this view, but not all the information on both views. In the whole drawing, you got all the information. But you might have to kind of interpolate and be like, how many would say 1.245 would be that dimension? Anybody going for that? Very well. I knew you would go with that. Too smart. Do you think that any of these numbers would apply to that? Oh, what are we going to do? Where do you think we should go?
With the spindle on the left right there.
Correct.
Around the circle.
Got it. And is it going to be this whole entire thing here? Very good. See, no, silly Christina. Yeah.
From that picture, how do we know what view we're looking at? We're looking at from the back and the front.
That is a very good question. And so there is information here with the lines that I believe we are looking from this side, but it's based on hidden line stuff we're going to talk about later. I don't think other than that,
Is the letter A with the arrows in it?
so that, what is that showing you?
That's showing
Outside
where
in.
they cut it out
Correct.
for the section.
Yep, that's showing that. Very good. Sometimes they'll say like front view, but if they're showing you this side of this kind of 3D version, typically that'll mean you're looking from this. And otherwise they would flip it.
Oh, I see, because there's a one for the sectional as well.
Right.
So they,
Yeah.
okay.
Yeah. So, did anybody find that? What number? 2?
2.
Yeah! I knew it. You guys are on. Very good. So, this line leading in here, and we'll talk about leader lines and all that, with a little 2 is talking about the diameter of this circle, which is also that circle, which is also that, because we cut this away right there. Yeah.
Does that symbol mean diameter? The left, the 2.0?
That
It does. Okay.
looks like it does in here. I always cross-check everywhere else and see, okay, what makes sense. Yeah. Because sometimes it'll mean there's no tolerance, but I don't see that here. Yeah.
Is it always in inches? Like that, I think.
Good question. Yeah, so in the United States, for FIA stuff, dimensions will always be in inches, unless otherwise specified, because something besides inches they have to tell you. Very good question. There's a Did everybody, let's see, and then you scroll down, yada yada, and click 2. Yay! And it should.
Right answer.
I should have done the wrong one. Anyone not get, yeah, not fill it in yet? Then, once you hit next page, that's supposed to save your previous work. You can go out of the lab, go grab lunch or whatever, come back, continue. So, that being said, make sure if you're going to leave the lab that you do hit next page so it saves your previous work. All right. Question 10. Examine the drawing below. Using the sectional view, so nice, they tell you which one to look at. Determine the overall length of the part. So that's talking from here
just go to the side and pick a number, does it save?
It should.
Okay.
Yep. Yep.
Just make sure.
This last one may not because you can only hit finish attempt. So just
Okay.
remember.
Did you press previous page? I don't know 100% for sure. It should. It should. So, hang on to that one for a second. So I'm going to talk about another lab, and then you can work on the two of them in the time remaining. So, I'm going to go back to this one. When you click on number 2, you're going to get a whole lot of nothing because it's a printed lab, which is this one here. So when you have a printed lab, on it has a place for a grade. So I'll put the grade on here. I'll put the grade into Moodle. There's nothing that you have to worry about in Moodle. However, what you do need to worry about, actually not to worry about it, just do it, is write your name on the printed lab. If you don't write your name, what Ryan and I have done the last couple of years, we started a pizza fund, and we didn't determine the amount yet for this year. Unless Ryan tell you, okay, amount yet to be determined. You get to donate to the pizza fund if you forget your name. Because if you don't have a name, then we have to go through, okay, who all do we have? Who do we eliminate? Who are our suspects? Figure out. And also, please write legibly. So, yeah. I don't have all your names memorized yet, so it gives me a really hard time to actually guess what a scribble is supposed to be.
So are we doing both the online and the paper?
Yes, and I'll tell you
Is Chris
what that
allowed?
yes.
Okay, there. My cursor is legible.
On the other way around, like, oh, that looks like fun.
That's a whole new kind of
Would you prefer phone name or what being known by?
Give them a line for us.
Either. Because I think I'm checking up the yes.
Okay, so, but it doesn't have to be the legal name.
Correct. All right, so first things first, everybody just write your name. Where it says student name. Then we can just have pizza for fun. We don't have to have pizza as punishment. So,
It's always a punishment.
brilliant. Because last year we didn't get enough in the pizza fund to get it for everybody. We had to change things up. So I like that.
Staff it.
Right. Let me just enjoy it in front of you. In front of the people that didn't write.
Rub it in, okay.
All right, everybody got their name written down?
Yes.
Very good. So, oh, and here on the front you'll see ACS reference, K1, K4, S2, S3. That's from your syllabus when I talked about the ACS and all those numbers. That's the code that tells you what parts of the ACS this covers. So, if you're curious. And then it's my fun little box to grade, my initials on a graded date. I fill all that in. You don't have to worry about that. Then there's really fun fill in the blanks. So, this you're going to see drawing A and the questions, drawing B, drawing C and D. These are the drawings that are out there that I carefully take down to the tables. So you'll go out there, no coffee or water at the drawings. You can have it on other tables if you want. Take care of the drawings. Don't be leaning over them and chatting with your friend. You can chat with your friend, but don't mess up the drawing. And then you're just going to fill in the answer. So for drawing alpha, it says number. You're going to look in the drawing and figure out what is the drawing number.
title, what's the title, and so on for all the information. So the reason I'm giving you 2 labs at once, there's 4 drawings, so maybe 8 people, maybe more, if you're all becoming friends. But like 2 people, 2 to 3 people a drawing at a time. So not everybody can be out there all at once. So in a minute, I'll have 8 people probably go out there. When they're finished, we'll cycle some more through. But if you're not out there, you can work on lab number 1 in here. So that everybody has something to do to stay busy and finish out the day. Yes.
For drawing A, if there's notes, do we just say yes, or do we just like write out the notes?
Excellent question. Write what the notes say. There shouldn't be, it should just be enough to fill in. Yep. Yep. Let me see if there was. Does it have, yeah. And I'll be floating around, walking around, not floating. Between the classrooms.
Anti-gravity technology.
Out there. So if you have questions, please ask during lab time. Very glad to, like that one. That was an excellent question. Because there's other stuff I might not catch. So, are there any questions on lab 1 or on this one? Okay. Before I release you all, make sure you're back in here at 3:15. That's not a spider, it's a bug. Oh. Back in the classroom at 3:15, so we can go over some cleanup duties and get all that covered. All right, let's just start with the back row. So 1, 2, 3, 4, 5, 6, 7, 8. Amanda, number 8. You guys can go out and 2 per drawing. If you have plenty of space, you can invite a couple more people out. And then I'll kind of be watching as they're shifting in. I'll be calling up the next people. So hopefully. So what? Oh yes. Yep. So for labs, use your textbook, use resources. Yes. And then the ones that are left, you can work on the Moodle lab.